Today we are trying to solve a sum of a series. The series in question is consecutive integers starting from 1. So let's take this particular question. We want to find the sum of 1, 2, 3, 4 and so on up until 200. This particular problem can be approached in multiple ways. One of the ways is to do the hardcore way, which is you calculate the sum of each and every individual numbers up until 200 and find the value. However, we are not going to proceed that way. There is a shortcut method and also an interesting formula to use in this particular scenario. The formula we are going to use was actually discovered by a German mathematician named Gauss. He is a very famous mathematician, and it is rumored that he found this formula or the approach to this to solving this question while he was at high school. You can pause the video if you want to solve this question. Alright, so we know that this series runs from 1 to 200. For this scenario, let us consider a simple scenario. So I'm going to find the sum of the series from 1 to 4. So let's try to do this. So we want to find 1 plus 2 plus 3 plus 4. Okay, this is very simple, and the answer is 1 plus 2, 3, 3, 6 and 4, which gives us the answer 10. Now to find out the formula, we are actually going to derive it so that you understand how the formula works and how we can apply it in complex scenarios. So we have the answer as 10, which is correct. Now I'm going to start deriving or trying to approach this problem in a different way. So let's take this first series. So we need to find the sum. We can write it as 1 plus 2 plus 3 plus 4. Now what I'm doing is, this is called the left hand side and LHS, and this is called the RHS, right hand side. Both are equal. Now what I'm doing is, I'm going to add the same equation one more time. So let's do, we have sum, and I'm going to add it. We have, so instead of writing 1 plus 2 plus 3 plus 4, I'm just going to reverse the series. So I'm going to write it as 4, and I'm going to bring the 3 here, okay, and then I'm going to bring the 2 here, and I'm going to do it 1 here. Now I'm going to add these terms, right? Okay, so I'm going to add it. So this side, sum plus sum will give me twice the sum, so 2 into sum equal to, right? Now let me add this. So 1 plus 4 equal to 5, then 2 plus 3 gives me 5, and 3 plus 2 gives me 5, and another 5 here. As you can see, mathematics is all about patterns. What we have done is, we have kind of like simplified this series into a single number. Now we can go ahead and try to have take another approach to this. This is nothing but 4 times into 5, which gives us the answer 20. But in the left hand side, we have 2 into sum is equal to 20, right? So let me write it, 2 into sum equal to 20, but sum is nothing but 20 divided by 2, which is 10. So we have the answer 10 here, which is from the straightforward method, and here we have 10. So what it proves is, this all we have done is this particular step. We have just reversed the series in this way. Okay, now we understand one neat trick here with the new step. Now, how can we find a formula from this? How can we generalize this particular step so that we can try to solve using this method to find the value of the sum until 200. Now, to find the generalized formula, I am going to just replace a number into a variable. Okay, I'm going to assign a variable to the number. So here I'm going to tell that let n equal to 4. This also represents the last number in the series. Now I'm going to create a table and based on this particular n. So we have 1, 2, 3, 4. This is the number and this is expressed in variable. So what I've assigned is 4 is equal to n. Now 3 I can write as n minus 1. 2 I can write as n minus 2. And for 1, for simplicity, I'm just going to keep it as 1. Now what I'm going to do is I'm going to use this table to try to find the generalized formula. So let's see what we can do. So we have sum equal to 1 plus 2 plus 3 plus 4. Now in the second row, I am going to write again sum, right? But I'm going to reverse as we did in the previous step, where we can this particular. So I'm referring to this particular step. Okay. So instead of writing 4, what I'm writing is I'm going to use this particular row. Right, so in 4 we can write it as n. Okay, so n plus we have 3 here. Okay, 3 is nothing but n minus 1. N minus 1. So I'm going to write n minus 1. Okay, and here I have 2, which is nothing but I come here and see, which is n minus 2 plus, and I'm going to write 1. 1 in this table, it is just going to be 1. Okay, so we have set ourselves a step. So what we have done is, just to repeat, this is the sum which we need to find the series of, and I am repeating this particular step, but instead of using the direct numbers, I am just replacing the numbers using the variables what we have here. Okay. Now let's try to solve this one. Okay, let's add the above rows. So here we have 2 into sum equal to, this one I can write it as n plus 1 plus again, so 2 plus n minus 1 will give me n plus 1, because 2 minus 1 is again 1, so n plus 1 plus 3 plus n minus 2 will give me n plus 1. plus 1 plus this one is going to be 4 plus 1, which is nothing but 5. Or in this case, I am going to replace the 4 with n from this table. Okay, so now again we have n plus 1. Now let's do it. 2 into sum equal to, so we can see that n plus 1, n plus 1, n plus 1, n plus 1. It has repeated how many times? It has repeated 4 times. Okay, so 4 into n plus 1. 2 into sum equal to, but instead of 4 I can write it as n. So here we go, n into n plus 1. Now sum equal to n into n plus 1 divided by 2. Finally, we have arrived at this equation. Okay, now let us try to apply this equation into the problem which we have solved. So let's go back to the previous equation. We are just going to test it out. Okay. So the series which we wanted to find is 1 plus 2 plus 3 plus 4. Now we know that n equal to 4 and sum equal to n into n plus 1 divided by 2, which is nothing but 4 into 4 plus 1 divided by 2, which gives me 4 into 5 divided by 2, which is nothing but 20 divided by 2, which is equal to 10. This is perfect. And we have got the answer, which is the same as we did in the previous 3 methods. Now let us try to solve using the same formula for the question, for the main question, which is nothing but one plus 2 plus 3 plus 4 plus all the way up until 200. Here we know that n is nothing but the last term in the particular series. So we have n equal to 200. Now based on this particular formula, we know that sum equal to n into n plus 1 divided by 2. This is nothing but 200 into 200 plus 1 divided by 2. Again 2 goes, keep it as 100. 100 into 201, which is nothing but 20100. That is the sum of the series. As you can see, once finding out the patterns, and from the pattern we have kind of like found the generalized formula and we have applied to the main question. And in simple terms, this is how mathematics evolve, and it helps us to break down bigger problem into smaller steps, and ultimately helps us to provide shortcut methods or intelligent methods to come to the solution in a faster way. Hope you have enjoyed this particular problem and the proof and the solution. Do have a wonderful time ahead. Thank you for watching.